After preparing your serial dilutions and center dilutions for the unknown solution, you then need to draw up some of your solution using a plastic pipette and place it in the cuvettes. Fill the dilutions up to the mark on the cuvette. Now that you are ready to measure absorbance, you first need to zero the spectrometer using a blank. First, wipe the sides of the blank across from each other with a Chem wipe. Open the lid and place the blank inside. Make sure the clean sides face the light and detector in the spectrometer, and then close the lid. Then you want to press the 0 button on the computer until you get a value of 0 or 1 very close. Now that you have zeroed your spectrometer, you are ready to scan across all wavelengths to determine the specific wavelength you need to test for these dilutions. So the reason why that we scan across all wavelengths is to ensure that the specific wavelength that we use relates directly to the solution being used. If you were to use the wrong wavelength, then your absorption values for the solution could be incorrect. Where the wavelength reaches the max is known as your lambda max, which is defined as the value where the maximum absorption is obtained. Remove your blank and place your stock solution in the spectrometer. You then want to hit the start button. Find on the graph where you have a max, hover your mouse over the maximum height and record the X value. This is your lambda max and will be your wavelength. Then change your wavelength and you are ready to measure the absorbance of all your solutions. To measure the absorbance, place the solution in the spectrometer and hit the read button at the top of the screen. The absorbance can be seen at the top left corner. Record these values into your notebook. Now that you are done with the lab, it is time to clean up your area. All the solutions can go down the sink and make sure that you clean everything out with soap and water and return everything back to their designated areas. So in this lab, we use Beer-Lambert's law in order to find the concentration of an unknown solution given absorbance values. This equation is absorbance equals molar absorption coefficient times concentration times optical path length. Generally, in this equation, the optical path length would be 1 and the molar absorption would be equal to the slope of your graph. Based on the equation, absorbance and concentration have a directly proportional relationship. So, if one goes up, then the other one must go down, and vice versa. So, your equation of your graph should be a linear equation. So, based on the equation, if you were to not zero a blank in the spectrometer before obtaining your data, then the absorption values would be incorrect, leading to an incorrect concentration. Here you can see the concentration of our dilutions and our unknown solutions. And then using a linear regression, we found the concentration of our unknown solution.